So good afternoon, ladies and gentlemen. For those who are outside India, good evening as well as good morning. I welcome you all for today's e-conference on unleashing the power of co-innovation in the chemicals industry, organized by Indian Chemical News, India's #1 portal for chemicals, petrochemicals and energy sector. The e-conference is supported by Schneider Electric, the global leader in digital transformation of energy management and next-gen automation. Let me introduce you with our esteemed speaker for today's e-conference, Dr. V. Venkataraman Balakrishnan, President and Head Global Sales and Marketing, Aditya Birla Chemicals. Just a brief on Mr. Balakrishnan. A highly accomplished and seasoned business leader with over 3 decades of professional experience, specializing in the management of specialty chemicals across diverse industry segments. He has been working in the present position for the past 10 years and has played a pivotal role in propelling the global business growth of the Advanced Materials Division. A postgraduate in chemistry with MBA in marketing and PhD in management, he has expertise in driving business strategies and fostering collaboration in challenging environments. Welcome, Dr. V. Venkataraman.
Thank you, Pravin.
Thank you, sir. Mr. Rajesh Kamat, the Vice President and Head, Sales and Marketing, Tata Chemicals Limited. He's managing a product portfolio which includes bulk commodity and specialty products across India, APAC, and Africa. Started his career as a strategy consultant and has worked with several Tata Group companies for strategic planning and M&A. He has also worked with Accenture and Infosys in operations and supply chain roles. He is also a member of various industry bodies/associations like AMI, IBP, and PENDA ETC. He's a chemical engineer from UDCT, now ICT, and also has done his MBA from IIM Ahmedabad. Welcome, Mr. Rajesh Kamat.
Thank you, Pravin.
Thank you, sir. Mr. Tapan Kumar Dhar, Senior Vice President and Group Head R&D, Berger Paints India Limited. Mr. Tapan Kumar Dhar is BSc Chemistry from Calcutta University, MSc Organic Chemistry, and MTech Polymer from IIT Kharagpur. He started his professional career with Jubilant Organics Limited. With over 27 years of work experience, Mr. Dhar was also associated with leading companies like Ulchem India Limited, AkzoNobel Limited, and Asian Paints Limited. Welcome, Mr. Tapan Kumar Dharji.
Thank you, Pravin.
Thank you, sir. Mr. Sanjeev Gupta, Director R&D, Shalimar Paints. He is an experienced technical head with a demonstrated history of working in the chemicals industry, skilled in paints, account management, product development, R&D, and coatings. Strong information technology professional with a PGDM focused in marketing from JBIMS. Welcome, sir.
Thank you.
Thank you, sir. Mr. VP Joshi, Head R&D, India Glycols Limited, with over 37 years of experience in industrial research, product development, process validation, quality control, quality assurance, and product development. Mr. Joshi has worked across diverse industrial sectors, particularly with the chemicals and petrochemical industries, with a specialization in various types of surfactants. He has specialized in debottlenecking processes and enhancing product value through frugal innovation for surfactants across various industries, including home and personal care, pharmaceuticals, oil field chemicals, emulsion polymerization, paints, agrochemicals, textile, paper, and leather. He is MSc in Organic Chemistry from HNB Garhwal University. Welcome, Joshi ji. Mr. Bhaskar Sinha, Director Innovation Lab, Schneider Electric. He is currently heading the Innovation Lab at Schneider Electric. As a techno-business innovation leader, he is tasked to identify the current challenges and future opportunities in various market segments and develop new solutions to unlock business value and generate new revenue streams. He was responsible for setting up the AI ML lab within the process automation line of business at Schneider Electric. He has over 25 years of experience and has launched several commercially successful products and solutions from concept to launch. He holds a BTech from IIT Bombay in aerospace engineering and MS from Mississippi State University in computational engineering. Welcome, Mr. Sinha.
Thank you so much.
Thank you, sir. Mr. Prashant Chandanapurkar, Senior General Manager, Innovation Lab, Schneider Electric. He has a passion of pioneering new technologies and driving innovation. He plays a crucial role in developing cutting-edge solutions to address industry problems. His expertise lies in conceptualizing and developing transformative solutions that help customers to drive sustainable business growth. More than 20 years of experience in working with digital solutions businesses for industries like water, chemicals, renewable energy, plastics, recycling, and automotive. He's a mechanical engineer with masters in business administration. Welcome, Mr. Chandanapurkar.
Thank you, Pravin.
Next slide. The key discussion points for today's webinar. Challenges in achieving collaborative innovation. Collaborative innovation can propel operational efficiency, sustainability, and digitalization. Better insights can help better decision-making, AI-based solutions, and strategies for building successful co-innovation partnerships. Next slide. So there is a IC and play and win context about the contest. I shall be asking questions from the delegates during the course of the session, and the one who responds fast with the correct answer stands eligible for winning rupees 1,000 gift voucher from Amazon. All the questions will be asked by the moderator of the session and replies to be given in the chat window. I repeat, all your replies to be given in the chat window box of your respective screen on Zoom platform. Final winners will be announced at the close of the e-conference session today at 4:30 p.m. Only the person with the correct answer responding first in order of priority shall be declared winner. Organizers and sponsor partner employees are not eligible to participate in the contest. Organizers' decision to be treated as final in case of any discrepancies. Gift vouchers to be sent electronically to all the winners post completion of the session. Next slide. Just a brief about Indian chemical news. We are having a page views of 148,760. Sorry, 670. Sorry, 760. Users 80,000. Newsletters is 49,000, reaches Monday to Saturday. Open rate of 30% and click rate of 8%. LinkedIn followers is 75,218. Recently, we achieved the 75,000 landmark. So with this, next slide. With this, I end my presentation. I would request all delegates to fill the Microsoft form. So the Microsoft form would be on the chat window. Please give the link, Saurabh. Please give the link for the Microsoft form on the chat window so that all can fill it up. Saurabh? Yeah, there is the link is there. Please click on the link, and it has 7 questions. It will take you not more than say 45 seconds. So without wasting any time, let me now request Mr. Prashant, Senior General Manager, Innovation Lab, Schneider Electric, to give his presentation. So over to Mr. Prashant Chandanapurkar.
Yeah. Thank you, Mr. Pravin. Let me just share my screen. Let me know if my screen is visible to everybody.
Yes, please go ahead, sir.
Yeah. Okay. So once again, welcome everyone. I'm going to walk you through the concept of what co-innovation is all about, and also covering and giving few examples and what we have developed solution working in the area of by going through the approach of co-innovation. So the first question is that what is co-innovation? The co-innovation is basically a collaborative process wherein ultimately the goal is to solve the business problems, and the approach is basically pooling resources, expertise, and ideas. But the most important thing about the collaborative approach here is that the problem statement or the customer is going to give a problem which is driven mostly by related with the challenges what they are facing. Typically, when we visit the customers, we see a whole list of problems, but that needs to be prioritized. And we work on those problems, work very closely with the customer, and say that okay, these are your top problems, right? Once the problem identification is done, as a Schneider, what we have is a complete innovation labs wherein we have ecosystem that covers our partner network, wherein we have OEMs, we have different type of universities, we have working very closely with a lot of startups, and also there is this partner network that is for different technologies, different skill sets, and so on, right? So the question comes is that okay, why we have to work with a co-innovation or collaborative manner? The first thing is that many times what we see is that the problems are very, very complex. You need not have all the skill sets available, not all the resources available. So that's the benefit of co-innovation, because it enables resource sharing and risk mitigation. What we also see our customers benefiting is in terms of time to market as such, because traditionally developing like that will take long time. But when you have development that is happening in this collaborative manner, which is much faster, it helps customers to develop age in terms of competitive advantage. You can even be better than your competition. There is also, when you are trying to meet certain market requirements, you can adapt to these market changes very quickly, and hence there is need for the co-innovation. These are a few examples. Now, co-innovation is happening in all the sectors. We are working with various types of industries. Oil and gas is there. Here are examples of few examples from seawater desalination to copper processing, and going all the way to some of these newer industries like green hydrogen production and so on. Right. But what's important to understand is that each customer, when we work with them, there is this problem statement that has been very clearly been defined, right? And there is time that we spent in defining the problem statement. Like, for example, when we are working in the area of seawater desalination, the problem statement for the industry itself is that you would like to reduce the total energy consumption for producing the desalinated water from $0.6 per meter cube to $0.3 per meter cube. Now that's the target. But what is stopping the industry, right? So it is stopping the industry because of the overall cost of this water, which is primarily governed by the cost of energy. There are a lot of machine learning based, AI based algorithms which are available in the market, but it is still not helping the companies, because the core problem there is that you are not able to measure the TDS, or what we call the salt in the water. And that is important, because all your control which is required, that at what pressure, at what volume you are going to pump the water through membranes, that is governed by these values, right? So that's the biggest impediment. So that's where we are working with industry in the area of seawater desalination, to help our customers to reduce the cost of desalinated water. Similarly, in the area of green hydrogen, we are working with green hydrogen electrolyzers, ultimately to reduce the energy consumption, improve the overall yield, and also improve the membrane life. There are also, it is important to understand that there are a lot of optimizations that needs to be optimizations that needs to be driven while operating the plant, because the load will depend, it will vary, and depending on the conditions, you have to also do the optimal operations of the plant, right? So these are few examples wherein we have been working with customers very, very closely. If we come back to the chemical industry, what we see is that what are the top 3 challenges of the chemical industry as such? We see that there are challenges in terms of regulations. Regulations are continuously changing, and even not just local regulations, but global regulations impact everybody. Just to give an example, the CBAM regulation, which is there in Europe currently, that got implemented in 2023, which is about carbon tax, essentially taxing the carbon which is coming inside the European Union. So far, it has been mostly with the metals, but now it is going to start to come by end of 2027. It is going to be also applied to other commodities. So even definitely chemicals are going to get impacted because of the same. Remember that it is not only just the measurement or estimation, just the estimation part of it, or reporting it. They are also looking at very, very close certification of the processes and things like that, right? So this is how basically it would even impact the companies or organizations which are going to export it into Europe. So these are some of the areas where the regulation impacts everybody. Similarly, when we look at raw materials, organizations are driven by developing raw materials, but you cannot develop your logistics, your supply chain that faster. You have to think about the performance, but there are also drives where we are looking for raw material which is more and more sustainable. And the third and the most important area is the talent. Given that the overall chemical industry is so complex, given the high skill sets which are required, getting the new talent and retaining the new talent is one of the problems. So these are top three global trends what we see with the chemical industry. What we also see are three trends which are in chemical industry. Again, what we call circularity, digital, and electric. Circularity is all about being having sustainable material development, ultimately looking at reuse, recycle, and regenerate. Even packaging material which is supplied with the raw material, that needs to be also reduced. It has to be it cannot be single use plastic. It should be very easy to recycle. So that is being getting applicable to even some of the just supply of the raw material as such. People are also looking at circular material, more of a green material that needs to be used in industry. So there is a lot of pressure which is coming based on the sustainable development goal, and organizations are now adopting it a lot as a green material as such. The next area is the digital part, wherein we are talking about not just the energy but making the energy smart. Here the biggest challenge is that how we can make the invisible visible, measurable, and also actionable. What we see as far as the chemical industry is concerned, we see still it is one of the laggards in the industry compared to other industry. But what we also see now that it is catching up a lot. We see a lot of solutions being developed in this area thanks to IoT, AI, machine learning, analytics, and also development of a lot of IT infrastructure, which is required to support the digital, is now already in place. So it is catching up very fast. The third area is the electric part, wherein we are talking about not just the energy but making the energy green. Here, electricity itself is the biggest vector for decarbonization. What is happening with electric is that it provides you an opportunity to improve the overall efficiency, and we can also replace the existing energy or electricity with green energy. For example, we see something like, for example, ethylene cracker furnaces. They are also becoming electrically driven. What we also see with example, very simple low-hanging fruits, like you can use the variable speed drives or variable frequency drives in terms of using it for motors and pumps, right? So that's where the trend is catching up for electric. Now, based on this, let's look at quickly few examples where we have developed the solutions for the industry. One example is especially for paints and coatings industry, and I'm going to talk and show you one of the biggest problem which we called as color matching. What is happening in case of a color matching, this problem is that it's a the current process of matching the color in industry, especially for industrial or maybe automotive paints, it is very iterative. The thing is that being a manual process, and also this process uses what we call as substrate or panels on which the paint is the panels are painted, and then you have the reference panel, and then you are basically comparing these panels. Based on that, there is something called as what is the difference or delta E, LAB value. Those are calculated, but you need also skilled people, who understand this, and based on their skill set, they will decide, to match the color, how much pigment or how much colorant that needs to be added. This is again very difficult process. It's a very manual process. So what we see in industry that it needs a lot of iteration, and it consumes sometimes we have spoken with a lot of plant heads. They say that it takes them 2 to 5 days to even match those colors and get the right results. So it eats up into a lot of capacity of the plant, and that's the biggest challenge that needs to be addressed. Also, when we look at the quality teams, they are overburdened. They are having too many samples coming to them. They have to test it again, give the feedback, and so on. So that's the biggest problem for the paints and coating industry, that how this color matching can be done. So what we have done is that we have developed a process in which we are completely eliminating this substrate-based testing. We are doing with a new method. It's a liquid or liquid sample-based testing, right? That basically helps you two things. One challenge what we see with this industry is that a lot of things still are done on the basis of on the piece of paper where things are written. If you have to refer something back, it is very, very difficult, right? So we have enabled the digitization part. And the crux or the basis of this solution basically is that we are using AI or machine learning based solution or a software here, which is basically helping and directly telling to the QC person that what quantity of this colorant that needs to be added. So this way, it is also improving the process, overall productivity of the process. It's boosting the plant production which is required. So by you are freeing up a lot of capacity which is there in the plant, which is getting today locked because of this wait time and the iterations, right? So that's the biggest advantage. Second thing is that a lot of these customers or your success also depends on how fast you are able to fulfill the demand of the market and supply your product. So that has been also enabled. And third part is that we are also doing the capture of the knowledge so that if you want to refer something in the past, it is completely digitized. So we would like to again iterate here. It has been done very closely working with the customers who are from automotive background here, automotive paints manufacturer. The second example is about raw material usage optimization. This is the case which is related with printing inks. For raw material consumption, now raw material, everybody knows that it is like 65% or 85% of the total cost of the product, right? So that's why it is very, very critical. The challenge here for the production team is that you have to meet the quality norms, like for example, viscosity here. You have to produce the right quantity and also ensure that you are having the ratio of, let's say, if it's a water-based paint or whatever solvent you're using to the other raw materials, like whatever you are using in the production of these inks is balanced. What we see, or when we went and had a discussion with these customers, their challenge was that for most of the industry, they say that either they meet the quantity, but if they meet the quantity, they are not able to get the right viscosity. Or when they meet the right viscosity, they either overproduce or they underproduce. Now, if you overproduce, then you have to basically manage all the inventory. There is a huge inventory carrying cost. Or then if you have to send it to incineration, then you basically lose margins for that particular batch. So that's the problem. And the second problem is that if you underproduce, then you have to repeat the batches and try to meet the quantity of the customer and again rework for the quality. So that's the pain for the industry. What we have done again here is a solution where we have deployed certain sensors and again integrate this solution with what we call it as a batch optimization engine, which is AI based. And this solution has first, what it does is that it provides insights. It detects which are the batches which are producing, which are doing overproducing, which are doing underproduction. You need to focus on which batches and so on. And secondly, this solution is also able to then provide optimization in terms of like how you can basically achieve those targets, in terms of viscosity, quantity, and the right material. So this is what the focus here is, more on the optimization and meeting your targets, right? Ultimately, when customers say that even if you save, if it is save 3%, for the customer, or 4% of the raw material cost, it's a huge saving for the customer, just because any type of a raw material that is going to add to the bottom line for that particular batch. So that's about the raw material savings part. The next example is a co-innovation, which is for industrial mixers and reactors. It's pretty generic, applicable to most of the chemical production or chemical processes. Here, when we went and when we discussed with the customers, what they say is that today as operators, they get a lot of data which is coming in front of them, but there is a lack of process visibility. What we mean by this is that there are two things. One is that either some of the critical sensors which are required for digitize the process, those are missing. Many times there are sensors present, there is a data being captured, but you are not making any sense out of the data because it's just the data which has been displayed. Like for example, only temperature is displayed on the screen. So just having a temperature is not enough. Process engineers, they are also looking at like, okay, what is the rate of rise of temperature, or they are looking at various parameters, and can it help me to know that, okay, at what point of time, let's say whether the temperature is going to go to a certain level within 5 minutes, 10 minutes, 15 minutes. That kind of a projection also they are looking for. So there is lack of process visibility. We also see conditions because of the reworks which are happening. It leads to a lot of excess energy consumption, the loading of the mixer, and so on. Similarly, the condition of the equipment is unknown for most of the operators till something breaks down, okay, or there is certain problems, which is then you call the maintenance and all. We have been to certain customers also. They say that when the the cost of the batch which is getting spoiled, the cost of it is more than what they are actually producing in the mixer. So that kind of a condition is there. So it is also important that you get this kind of a feedback about the downtime, and they have absolutely no idea about it, right? Ultimately, it leads to poor quality, iteration, and lower yield. So what we have done is that we have developed this smart equipment solution. And the basic premise for this is that, a simple thing you can say that, yeah, phone is getting smarter, there are television is getting smarter, all the products in the things, getting smarter. Why not we think about industry, right? So as a part of, driving industry of the future, what by doing this we are achieving is a smart, efficient, and sustainable operations of the plant, right? And it's a part of our strategic vision where it is playing a pivotal role, and we are adding a lot of intelligent to even a traditional equipment, right? So idea is that we drive this more autonomous operations, improve the efficiency and productivity, safety, and so on, right? So there are multiple use cases and benefits where this can be deployed. But again, the steps remains the same. We are first providing the visibility, then we are providing the insights, and then we are driving the optimization. A very simple example that what one of the operators has told us is that they are asking if there is a liquid and you are adding certain solid to a reaction which is happening, or maybe a mixing which is happening there. Many times when you add this solid, it has been told to the person who's on the shop floor to add it gradually, but nobody's there to monitor. It's impossible to monitor each and every person, so they put it in one go, and then it suddenly the density goes up, the viscosity goes up, and it creates a lot of load on the impeller which is there, right? So that creates a problem. The bearing breakdown happens and things. And if you look at it, such kind of a problems are very hard to detect if somebody is doing it, right? But that's the idea. By deploying these kind of a systems, you will get an alarm, you will get a visibility that something is going wrong, and before any anomalous condition develops or any runaway reaction happens, you will be able to get the feedback. So that's what the whole solution is all about. At least in the interest of time right now, we won't be able to get into the details of this, but I think we have already pasted a link there. So if you would like to know more about these solutions, if you would like to understand more, have any queries, we would be happy to get in touch with you. So please fill in that form, and we would be happy to get back to you. So again, with this, I would like to end my presentation. Thank you for the opportunity, and I'll hand it back the session back to Mr. Pravin. Mr. Pravin, over to you.
Thank you, Mr. Prashant Chandanapurkar. If you have any questions, please write your questions on the chat window. We can take it up later, or I don't see any questions right now. We will take it up later if they come up. Before we go for the panel discussion, let me request all delegates to get ready for the ICN Play and Win contest. I repeat, please type replies on the chat window so that there is no discrepancy. So please type replies on the chat window, and my question starts right away. The first is, next slide. Co-innovation is particularly valuable for solving complex challenges that require diverse expertise. A, true. B, false. Please give your answers. Simple, very simple question. Now we come to the second part. So next slide. Next slide. Which underlying technology is used for the batch optimization solution for color? A, artificial intelligence. B, virtual reality. Now let us come to the third part, which is the next slide. What is the biggest problem for operators today to operate industrial mixtures and reactors effectively? A, lack of process visibility. B, lack of batch sizes. Thank you for the answers. Now we come to the most important part of this e-conference, which is the panel discussion. And the theme for today's panel discussion is unleashing the power of co-innovation in the chemicals industry. We have got a very elite panel, Dr. V. Venkataraman Balakrishnan from Aditya Birla, Mr. Rajesh Kamat from Tata Chemicals, Mr. Tapan Kumar Dhar from Berger Paints India, Mr. Vinod P. Joshi from India Glycols, Mr. Sanjeev Gupta from Shalimar Paints, Mr. Bhaskar Sinha from Schneider Electric, and I will be the moderator for this session. So without wasting any time, we have a set of 8 questions that we do have. I request of all our speakers to speak for 60 seconds. I would request only 60 seconds. You can explain it in your second and third round. And the first question is with respect to how are you looking at co-innovation in your company? And to start with, Dr. Venkataraman Balakrishnan. Over to Mr. Balakrishnan.
First of all, Pravin, congratulations to Indian Chemical News and as well yourself for initiating this panel discussion topic, which is more relevant for the current context, right, where the industry really lacks innovation and really need to work on this direction, number one. Number two, just looking at, from Aditya Birla Advanced Material, we, as a company, we are truly a customer-centric organizations, and we create value to our customers by working with them through some partnership and collaborations. And not only the partnership with our customer and also with our, suppliers. And also we do have some external collaborations, we call it universities. For just to give an example, recently we collaborated with Oak Ridge National University in US, along with one of the partner Orbital Composite, to create a recyclable 3D printing composite. The idea is to create a recyclable composite as well as to reduce the productivity of making the wind blades. Normally it takes around 25 to 30 hours to make a wind blade. Whereas with this technology, it has been done with 5 to 6 hours. We won a global innovation award in the recent CAMEX, exhibition. So just to give an example, that innovation is part of our DNA in this business. And just to give you some quantifying numbers, we consistently invest in our R&D. Today, we do have Center of Excellence R&D centers created in Thailand, India, and Germany. We are also creating one in US. And today, if you look at it, we have Center of Excellences for certain segments like, wind segment, coating and construction, where we are working in creating a lot of waterborne technologies, BPA-free epoxies, lightweight, high strength, kind of composites, applications, recyclable composites, green and sustainable product. These are our focus. And also we have currently filed for 130 patents as a company advanced material business, and 60 patents have been granted to us. And we have a strong innovation pipeline as we speak, and driving growth in high performance, green and sustainable and recyclable products. That is Aditya Birla Advanced Material to you.
Thank you, Dr. Venkat. Now I come to Mr. Rajesh Kamat and your introductory views, sir, for 60 seconds.
Yeah, thanks, Prashant, and good afternoon to everyone. So what I can say is that at Tata Chemicals we have a very strong focus on co-innovation, and we take it very seriously. We have established many partnerships and collaborations to drive this innovation. Just to kind of give you a sense, we have 3 R&D centers. We employ more than 200 scientists. We have filed for more than 100 patents. And we have several partnerships. So we have partnerships with academic institutions. We have partnerships with government research institutions. We have partnerships with other industry players. We also have partnerships with startups. Now, these are all partnerships which are done with some specific purposes. Where we are looking to get some specific skills or experience on board, or certain product expertise on board. We also annually we conduct what we call as hackathons. These are innovation hackathons where we just the way it happens in IT industries, where we invite scientists, we invite other startups, and we just kind of spend a day or two just discussing and collaborating and trying to come up with fresh ideas. What we work on are both on our existing set of products as well as new age ideas, like for example developing sustainable materials, working on nutrition and health, which is a new area that we have recently got into, and this has been completely driven by our own internal R&D along with collaboration with other relevant agencies. Beyond products, as Dr. Venkataraman also mentioned, we look at collaboration across the board in, let's say, for example, in areas like supply chain, where we are working with vendors, with our other partners in developing innovative solutions, or in solutions where we can offer something new to our customers. And of course, last but not the least, we are also working with several of our customers to co-create products, or we work with our customers to identify either their existing or unmet needs, and we try to develop solutions jointly along with them, leveraging our skills in our own research centers as well as the networks that we have created. Yeah, so that's the summary from Tata Chemicals.
Thank you, Mr. Rajesh Kamatji. Tapan, Kumar, Dhar, sir, if you can talk about a brief intro.
Yeah, good afternoon, everybody. Thank you for inviting me for this panel discussion. It's a good now that already two speakers have already spoken. So my part, I will be very crisp, only giving a brief idea about what we are doing here. Try to be within your 60-second limit. Let's see. See, when we talk about innovation, it's about the process which really either create or change something which creates value to the organization. And this innovation, as the panel discussion point, is the co-innovation. It can be, one person cannot do anything. Co-innovation can be, the other partner could be lateral, partner, the stakeholder, or it could be internal as well. So the way we look at it is if it is a mega project, we go for external collaboration, and if it's incremental innovation, we bring people from different expertise within the organization and try to deliver the product. So that's how we go for differentiating between normal innovation and mega type of innovation or complex projects. We do take help from different institutes and academic research institutes, as well as IITs and some of the CSL labs also, which I'll talk in the next point. But the point is, that how really, whenever we take up a project, we really see whether it really adds value or not. And what are the problem statement, as in the very beginning it was coming, that once we collaborate, the objective or the goal share should be shared, nicely, and the deliverables to be very, very crisp. Unless the deliverables are very, very fixed, we do not really find much of the value with the external collaboration. So I think in the next part when I'll be, talking, we'll be really talking on that point. So that's how we manage the innovation at our, R&D center. I'm not going to talk about our products or different things and all those things. So, we also take on, the customers into consideration so that we can really co-create along with the need of the customer. That's how we manage the innovation here. Thank you.
Thank you, sir. I will now move to Mr. Vinod P. Joshi to give his introductory remarks on how he's looking at co-innovation in his company.
Yeah, hello. Yeah, thanks, Pravin ji, for giving me opportunity to talk about this unique topics. And today, this is the very important topic for all the chemical, especially in the chemical industry. So basically, co-innovation is a collaborative approach where the companies works as a partners with a partner, supplier, customers, or even though competitors to create the new solutions and make a tailored solutions that meet the specific requirements. So if we can go for the co-innovations, as far as my opinion, there is the 6 key points which should be clearly specified before going to the partnership, like alignment of the goals of both the party. Second one is open communication as a transparent way. Third is customer-centric focus. So customer is a god. So we keep the customer in the center for our innovations. Fourth is trust and risk sharing, and of course, flexible IP management system. So in past, from the India Glycols, we have done this model with our several customers in India, and we develop the product as per the customer need with the customers with interactions. Even though we frame out the specifications also products, so the resultant is the businesses remain last 20-30 years with India Glycols. So this is the one of the good part of this partnership for the long-term sustainability and business model. Yeah, thank you, sir.
Thank you, Vinodji. Now I move to Mr. Sanjeev Gupta from Shalimar. Sir, your introductory views.
Hi, everyone. Actually, that's why looking at the current scenarios with the industries moving forward, everybody is expecting a higher performance, actually. Everybody is expecting, all the customers are expecting basically a life improvement of the products. If they are using a product for X, maybe you have to have 2X performances, etc. So which I feel is not at all possible if you can do on your own. It has to be collaborated. It has to be collaborated, work together, get that operational efficiency, stabilities, the performance testing actually, because many of the things like in some of the areas of work, the expectation of the customer is a performance level to the 15 years, 20 years, performance warranties to the tune of 15 years and no failures. Now that level of performance warranties, etc., will come by basically working on with the testing agencies, laboratories all across the world, and collaborating with them to have a system where you can predict that level of performance in advance actually when you develop a product and offer it to customer. So collaboration is one of the very, very important things in our organizations. Like we outsource our most of the resins or cross-linker developments, etc., through collaboration routes, develop the new products actually. In fact, we collaborate a lot with end customers also. Like how can I eliminate waste? A waste for me, maybe a customer also is basically a waste for full organization, and that gives you a point of innovation and develop a new things actually. So we work with them, find out what can be a waste like and eliminate together. And we have seen lots of like appearance improvements, etc. These are lots of parameters which you as a one organization just cannot do. You have to work as a team with 3-4 companies together to come to a common goal and deliver a product actually. So that the collaboration is the only buzzword. You cannot survive actually in this context today without collaborating actually.
Thank you, Sanjeev ji. Let me come in the first round with the last speaker, Mr. Bhaskar Sinha, and let me get his introductory remarks.
First of all, thank you for having me here. And it's great to participate with the esteemed panelists here on this topic, which I'm very passionate about, which is co-innovation. So we belong to Innovation Labs, which is a special unit carved out of the R&D to solve hard problems which are high value for the customers. And the method used here is through the co-innovation. So we look at 4 aspects. One is about the domain understanding, the market trends and the forces, the technologies which are upcoming, and the skills that are required. And then we use this concept of co-innovation where we have the customer at the center, and then we bring in the network to solve the customer problems, which includes the OEMs, the startups, technology partners. You have the universities, the research bodies, domain consultants, and also our vendors who bring in the special skills to solve these problems. So this is how we have been performing this journey of co-innovation over this last several years. Thank you.
Bhaskar ji, we have come to the end of the first round. Now the second and third round would be a mix of questions. We'll give 2 questions to each of our panelists. The second round is with respect to what has changed over the last 2-3 years in the chemical industry in India and what is driving these changes. And here I would request views from Rajesh Kamat ji, views from Mr. Tapan Dhar, Mr. VP Joshi, and Mr. Sanjeev Gupta. And I would request, sir, because of the time constraint, would request you to keep so that we are able to make up for whatever the time that we get. To start with Mr. Tapan Dhar for his views.
Yeah, so the question was, what has it changed in last 2-3 years? Yeah.
And what is driving these changes?
What is driving this change? Yeah. Of course, I am, coming from a consumer good industry. So I am from paint industry. So my response are going to be based on the experience from the paint industry. So, so whatever I say is particularly related to that, but maybe we can extrapolate from there itself. See, now, if you see as a person, everyone is consumer. So what is happening is, nowadays, the market is fast changing, So there is no any fixed requirement. Every day, a lot of new models of telephone and all those mobile phone and everything is coming. So it's a changing market. Competition is also increasing. And also people are becoming restless. Everything they want yesterday. So the speeder, faster delivery is one of the requirement. Then also another point is coming is multiple attributes of any multiple features. When you earlier, if you recall, when you are using telephone, the phone was used only to make a call. Nowadays, on your hand, your smartphone can deliver everything. Similarly, on the goods also, consumer goods as well as the paints also, like Mr. Gupta was referring to, the people's expectation is that you need to, paint has to decorate. But apart from that, what else extra it can give? So this is another point, what extra it can give, which also the long life, can it give something else? Can it help to reduce the temperature of my room? Can it also be useful when my kids is making it dirty and it is easier to remove the stain from there? So the things and references are changing. And also, if you recall that now these paints are being, advertised by the different brand ambassadors. So the expectation of the customers is also coming that, okay, it has to be, certain feature has to be like that. Like when some big sort is advertised, when the expectation is not beyond the specification. So the product is going beyond the specification. So customers' requirement is changing. Third point, I would like to say that people can visualize things now. So even you can see how the wall will look like. So the expectation is that, okay, you are giving a product which can be really people can have a reason to believe to that. So reason to believe, customer demonstration, and also customer delightment. He's expecting it's not only performing on my wall, and also can it add some value? Can it repel mosquito? For example, some of the paints I could see. Can you also give energy, radiation proof? Can it hold the temperature inside? Can it be bacterial or bacteria free? So these sort of expectations are coming, and also at the same time, and now people are also expecting that the paint should survive for longer time, and also convenience. All of us now, want one phone call and the Uber or Ola, the car should be at here. So similarly, delivery, faster response of painting service is also coming to the play. So this is what the technology, and people are becoming knowledgeable. So these are the driving factors, and social networking. If one is, when we buy the newer generation, they're buying paint based on or any material based on the rating. I want to buy this. Let's see what's the rating of this. So overall performance has to be really robust. If someone is giving a negative comment, he is not going to buy again. So that is what the challenge of the basically technology is, how to deliver a product which really can give very good feature and also customer satisfaction, and also it has to be convenient to the customer. So this is what I would say is coming mainly the main change from the last 2-3 years.
Thank you, Mr. Dhar. I now move to Mr. VP Joshi. And sir, your views on what has changed and what is driving these changes.
Yeah, thank you, Pravin. So basically, in the chemical industry in India, there is a significant growth driven by increasing in demand in key sectors like pharmaceuticals, agricultures, and electronics. So these are the basically three major sectors where the demand is increasing. This key changes actually include a shift toward the self-reliance. Means Atmanirbhar under the Atmanirbhar Bharat programs, the rising investment in the chemicals, specialty chemicals, and a strong focus on the sustainable and green chemistry. So these are the main points which there is a significant change in the chemical industries. So we have some 2-3 observations or point like shifting toward the green chemistry and sustainable. So company is increasing, focusing on the sustainable practices, investing in green chemistry, and adopting the more eco-friendly process and materials. So basically, the major drivers for increasing this or focusing on these chemicals is the rising environment concern, basically, and regulatory pressures both from the domestic, even though India committed to the climate goal. So we have the commitment on the net zero programs, and so that's why this shifting toward the green and sustainable chemistry is the main drivers, or the demand the green or sustainable product from the consumer end. This is another factors. And there is a investment in the specialty chemicals. The specialty chemical segment, including chemicals for the pharmaceuticals, agrochemicals, personal care, even though in the water treatment, has been significant growth in the past years, because India is emerging as a preferred sourcing destination for the specialty chemicals in last 2-3 years, because the driver is global supply chain diversification, particularly the China plus one. So that is the main strategy. Everyone is looking for the India. So there is a significant change this specialty chemical segment. Thank you, sir.
Thank you, sir. Now I move to Mr. Sanjeev Gupta.
Yeah, yeah. Thank you, Mr. Pravin. Just I'll take on from Mr. Dhar what he has taken. See, what is the change actually? If you look at the biggest change is customer, exactly. Customer has become more knowledgeable because of availability of knowledge actually easily. And industry basically also has got the knowledge actually, or has an ease of availability of knowledge. Now you can get patents far easier. Basically, you know what's going on, what technologies are getting operated globally. And so Indian industry is also getting much more competitive. Industry is driving basically efficiency at every level, actually. What basically was presented in some of the innovation stories, actually, they have become basic now, actually. And that's where basically it's driving, like each industry wants to be like want to compete with China. That's what is exactly why. How can China can make a product which is cheaper than me? So that's what I feel is that there is a competitiveness has come in Indian industry. Everybody looks at that. Can I export actually? Can I produce at a lower cost and improve my profits basically? So that's one big change actually is getting competitiveness, how to improve my knowledge base, skill levels at the team, become more self-reliant actually. Another big change is what I see is the change from the government. Actually, there is a lots of push from the government to improve the basically Indian industry. It's just not getting cheaper import from China. The government is pushing us basically like why can't you make it in India? I'll give them examples. Nobody was making monomers in India. And because it was not viable actually, then what happened is government pushed their own companies like BPCL and Indian Oil to make monomers actually. And now India has started making monomers. So that's where there's a big change in the government actually. Government is pushing, giving up. Yeah, like look at the example. Government wants to set up a 50 50 GW of captive power consumption in India through batteries actually. There's no infrastructure in India as of now to make cells actually, battery cells, but still government is driving actually. So it's a both way. There's a big change from the government. Government is pushing. Infrastructure is being made by available government actually, and government is doing from lots of things from this side actually. So that's one. Industry on their own is pushing for, like, when you want to export or want to be seen better, actually, you're working on sustainable chemistries, actually. So sustainable, then you look for sustainable raw materials. Now, sustainable raw materials, Indian raw materials manufacturers are pushing up. I'll give an example of Aditya Birla. I have worked with them on sustainable epoxies, actually, which are workable, actually, and workable. Yes, Indian industry was working only on the cost first. But now it's not the cost is not it's the performance, adding value to the customer actually. So that's where is important actually. And Indian industry, and all I've seen is again a big advantage is manufacturing, taking up all the latest digital technologies into the manufacturing. That is a big change actually, transformation in the manufacturing processes. Your like IoT or AI, like nowadays, I'll give an example in paint industry. The industry has gone to the level where if consumer buys a product, that moment the manufacturing company will know this products are being sold. Then they can plan their raw material inventories, and manufacturing will happen by that. Raw material sourcing will happen with that. And that will eliminate basically the waste which was generated because of inventory. So there's a huge change in the involvement of your IT actually into the manufacturing, into every level. Supply chain is transformed totally actually. If you look at that, it is everything is now scanner based. You scan this thing, you will get all the information available at the tip of your this thing. Then regulatory compliance. In fact, nobody was looking at regulatory compliance in India. Now, everyone is talking of regulatory compliance. People, though many places, I'll give an example, some examples like the chromes, which are banned for decorative segment, but in industrial it is not banned actually in paint segments. But still, many companies, many global companies have gone ahead, and from their own side they have taken a call actually, and they have eliminated which is carcinogenic product to the customers actually. So there is a huge that way, and I find there's a lots of effort done from the industry into their research and development actually. More investment is going into research and development to how to make a differentiated or a new products. Look at the number of patents India is generating now. Yeah, it's still insignificant compared to China, but still the number of patents by the institutes, etc., is improving actually. So that's what, like, there's a lots of changes happened actually. And that's what competitiveness of the industry is working on towards that.
Thank you, Mr. Gupta. We move to the third part of the, and this is about how do you see the chemical industry shaping for the next 2-3 years. This is more of a futuristic projection that we are talking about, and the changes that you see in terms of demand, regulation, and technology. And here I would like to bring Mr. Rajesh Kamat first, and then Mr. Bhaskar Sinha. So over to Mr. Rajesh Kamat.
So, Pravin, the changes that we will see over the next 2-3 years is really, in continuation with, what we have seen over the last few years. So it's a gradual shift which is happening, and especially, post-pandemic, we have seen some specific shifts, which are happening. So I completely echo with, the views which the panelists have expressed to the earlier question, because what is going to happen over the next 2-3 years is, pretty much similar to what had happened over the last 2-3 years. But still, let me call out a few areas, which are turning out to be quite important. So if I look at, so you asked this question on 3 areas, so demand, regulatory changes, and technology. So if we look at, let's say, demand, I think there is a very clear shift, to sustainability and, green chemistry. Meaning there's a growing demand for sustainable and eco-friendly product. Now, this is a trend that you see not just, at a B2B level, but even at a B2C level. The consumers are getting more and more environmentally conscious. And, for me, we are a completely B2B company. And obviously, all our customers are asking for, asking the question, are your products becoming greener? So that's a very big trend for us. Second, is this entire thing around, the energy transition piece, which is where we have seen a lot of the, electric vehicles and storage solutions or solutions related to green electricity, all of that come in. And I think, products and chemistries related to that, I think, will gain very significant prominence. So just to give you a sense, you see the kind of growth that we have seen in glass, particularly for solar glass application. It's been phenomenal. We have not seen that kind of growth, ever in our history. Similarly, if you look at, growth in chemicals which go into EVs, and the EV technology itself, even that has undergone significant changes, and we can continue to see that, trend over the next 2-3 years. Third is in terms of healthcare. So, people are looking at, ensuring that they are healthy, both preventive as well as curative. And that also opens up a lot of opportunity for India from a manufacturing standpoint. Now, if I look at regulatory changes, I think this is kind of moving in tandem with the demand change trends. So clearly, the environmental regulations will continue to get tightened. The government obviously will be expecting the industries, and of course, we are also signatories to a lot of conventions and have committed to a certain glide path for reducing carbon emissions. And the government will continue to push for regulations, which take us along that path. Second is, of course, this and earlier. Mr. Joshi also mentioned about this Atmanirbhar Bharat initiative. Essentially, it's all about becoming self-sustainable, and particularly post-pandemic. While earlier we used to call there was a big trend on globalization, but I think now the trend is more towards gated communities where either countries individually would want to become Atmanirbhar, and it is not just about India. Or, you pick and choose a few countries with whom you would want to strengthen your trade. And therefore, you would see a host of these, individual groups, there's a group in Southeast Asia, there's a BRICS group which is happening, and there's so many groups which have come about. So they want to kind of, there's a lot of this groupism, which is what you're seeing, and you'll see regulations, which come around these lines as well, not just in India, but globally. Third is in terms of safety and compliance. So safety, at least within the Tata world, and especially for Tata Chemicals, is a is the most important thing. It takes precedence over everything else. And I guess, from a regulatory standpoint also, the government would continue to ensure that, safety gets that eminence, not just, for humans who are working within the plant, but also from an environmental perspective. The third area that you asked about are technological advancements. I think clearly, no surprises here. Digital is the buzzword, and it will continue to be there. In fact, it will continue to accelerate over the next few years. You will see increasing adoption of a lot of digital technologies, including artificial intelligence, massive amounts of analytics, Internet of Things. So all of these really go towards helping organizations in really improving operational efficiency or optimizing supply chains, or just ensuring that the customers get the products with a lot greater degree of certainty and reliability. And of course, one would also look at these technologies to improve the product quality or even the speed to market. Second is in terms of research and development. So while the legacy processes, so for example, we make a lot of soda ash. So fundamentally, there is not much change in the core soda ash process, but there could be developments in the peripheral areas, and therefore, one can see increased investments in R&D, which lead to a lot of innovative products and also innovative processes, and which is where collaboration between industry and other agencies, so be it specific startups, be it government institutes, or be it universities or specialized research houses. I think collaborations will make a lot of sense in this area. So yeah, just to conclude, I think, as I said earlier, the next few years will see a continuation of a lot of the trends that we have seen, especially around sustainability, digitization, and product innovation. Thank you.
Thank you, Rajesh ji. And I would come to Mr. Bhaskar for his views.
Thank you. I think just to add further to what we heard from our panelists, definitely whatever we have seen over the last 2-3 years, we are going to see this accelerating now over the next 2-3 years, right? And there are a couple of things in addition to what was mentioned. Our GDP is growing, consumer behavior is changing, as you rightly mentioned. But one thing is there that the per capita consumption of India compared to other global economies is still lower, which means that there'll be a further demand on these kind of new innovative solutions, or more demand from the industry to give them something better, faster, cheaper, right? So that's definitely going to happen. And again, sustainability, circularity, electrification, digital, these are all the trends which are kind of pushing this forward. Now, one of the things that we have been seeing over the last several years, and we have been tracking, and we are seeing that it's kind of expanding, is the interconnect of these various industries, where no more we are seeing that the industries are in silos, but they are interconnected, and they are kind of getting into each other's territory and domain, which is making it very complex. At the same time, chemical industry is becoming more like a central focal. And let me give some examples. If you look at the steel industry, I mean, they are one of the top polluters, and they are looking at how they can reduce the carbon footprint. This is where they are looking at green hydrogen, for example, to use as a reducing agent. Now, there are various sources of green hydrogen. You can get it from biomass or different sources and so on, but also from water by splitting the water, where you split the fresh water and get the green hydrogen. Now, where do you get so much of water? The water will come from, let's say, seawater, which is desalination, where you use reverse osmosis and chemicals to produce this fresh water, but there are challenges. Now, one study says that the brine which is there, if you just produce the chemicals from there, it's going to be, close to around $16, per kg, and you can literally give out the water for free, right? So there's such kind of, innovations or things that could happen. Now, if you look at the steel industry again, we have seen that they are also getting into, let's say, the coating and paints industry. And the paints industry, if you see, they're also moving forward to integrate the supply chain where they're trying to get into the raw materials, which is the hardcore chemicals. We talked of resins and monomers and so on, right? If you look at, let's say, the metals industry, they're also looking at sustainability and they're looking at carbon capture. But what do you do with that carbon capture? You convert them into useful chemicals, which again, you reuse into this industry. So all in all, the industry is getting interconnected. And this is something which is quite exciting and opens up new opportunities that we are seeing in this market. Now, traditionally, we know that India has been labor intensive and cost sensitive market, but it's changing now. There is a lack of skilled resources that we need. And all this is pushing towards the future, which will be more on automation and digital. And of course, we have to bring these technologies in a cost-effective way still for our country to make it, adopted by the mainline. So putting all these things together, it's not easy to get all these things delivered in a cost-effective way, all these innovations by a single player, and you need a collaborative approach to bring all of us together through this co-innovation journey or the concept.
Thank you, Bhaskar ji. I think the more we are interconnected, the more co-innovation is required. More we are talking about sustainability, more co-innovation is required. And as somebody said that since customers want everything to be done at the earliest, then the only best way is to co-innovate. Because then only what you think or what they think, you are able to bring to the market as fast as possible at a cheaper cost, so that you are able to capture the market at the earliest before others can do it. So we move to the fourth part, and here Rajesh, continuing with what you said in terms of demand, regulation, and technology, I want to again ask you, with respect to the complexity of the future, do you see it would be possible to solve these challenges alone, or would you prefer a collaboration among various partners or people sitting here or outside?
So Pravin, the short answer to your question is no. Given the complexity and the resource requirements, to solve tomorrow's problem, it is clearly not possible for any individual company or organization to really, tackle that. You definitely need collaboration, and we have seen, and we have seen that happening. So even if I look at my own organization, as I mentioned earlier, we have a R&D center, but we do a lot of collaboration with other organizations. As I said, including our own customers and vendors, because different people will bring in different skill sets, and also the risk and the resources then get spread out, and it then becomes much easier to solve the problem. Collaboration can take many forms, such as partnerships between companies, research institutions, industry alliances, and we have seen this happen because it, as I said earlier, it helps in sharing of risks and costs. Moreover, if we take, let's say, and I was just kind of doing a little bit of Googling to see, what could be the examples of some of these, collaboration that we are seeing at work. And, unsurprisingly, we see a lot of such collaborative actions happening in areas, which are very relevant today, which are today's problems. Say, for example, on sustainable plastics. I came across this example where, companies like BASF, Dow, Unilever have partnered together, and, of course, it is coordinated by NGO, and they're aiming to develop biodegradable and recyclable plastics. Now, suppose they succeed, it is something that it's not going to be restricted to them alone. It's something, it's a global problem, and I guess when one such collaboration happens, the solutions are also globally available and applicable. Similarly, if you look at carbon capture and and utilization. It's another huge problem. Everybody has got commitments, as to what their carbon emission levels are, but nobody knows what, solution is. So even, in our organizations, we are working with a lot of consultants, a lot of startups, to see if we can tap into certain solutions, which we may not be aware of. When I looked at, across the industry, I'm seeing, the likes of Linde and others, work collaboratively, to advance technologies which can help, improve carbon capture and, convert them into other useful chemicals. Or, if it comes to, say, for example, bio-based chemicals, So today, there is a big shift away from fossil fuel-based chemicals to bio-based chemicals. But again, there are enormous challenges, all the way from figuring out, where to get the reliable raw material or feedstock from, what kind of new chemistries should we use, because all these chemistries, would say, for example, something like fermentation as a technology. Now, fermentation is as much of an art as a science, and the more you collaborate, the better the art, really becomes. Similarly, I could go on about it. There are examples where, on digital transformation. So we also are, for example, collaborating with our customers, on creating digital platforms which help the entire, all the transactional activities can be automated. And I'm sure, at an industry level, you would see many examples where, such initiatives are happening. Similarly, I think one of the best examples that we have seen in recent times, was this entire thing, when COVID happened. There was a very, very pressing need, to get a vaccine solution to, ordinary people in the quickest possible time. It was a problem which was never attempted, which was unheard of. And 6 years ago, if somebody had told me that one could develop a vaccine within 1.5 years, not just me, anybody would have laughed, because a vaccine of that kind of complexity would have required at least 10 to 15 years to develop. But the need was there, and need is the mother of all inventions. And lo and behold, the governments came together, large pharma companies came together, niche research institutes came together, everybody came together, and the entire time to product development was absolutely slashed. And we had vaccines. Now of course one can question the efficacy, etc. But the fact is that the vaccines or the solution was available in record time, and it saved countless lives. And it pretty much it was the end of the pandemic. Just imagine, if there was no collaboration, what would have happened? 5 years down the line, we would have probably still be sitting in our homes, quarantined, not figuring out what to do, and the global uncertainties would have. So collaboration, Pravin, and just to kind of summarize, the answer to your question. Yes, collaboration is absolutely required. It's extremely critical, and especially so for tomorrow's problems.
Thank you, Mr. Rajesh Kamat. We move to the fifth part. I request, we are running short of time, so would require you to give short answers. The fifth is with respect to the potential gaps you think should be addressed to help drive co-innovation effectively with end users and partners. Here, I would request Dr. Venkataraman Balakrishnanji, and then followed by Mr. Tapan Kumar Dhar. If you can unmute yourself, Dr. Venkataraman.
Yeah, sorry. So when you talk about this, co-innovation, with your partner, whether it's customer or a supplier, right? The most important gap, if you look at it, I think it's a mindset and an open, lack of open innovation program, right? What I mean is, I think people should have a very structured innovation program where there's a transparent communication happening to understand the value, to create the value. That is something, one area where we need to work out. Number two, even if there is a value that has been created, the challenge is who captures the value. Is it the customer or the supplier or so that's where the clear guidelines in terms of, intellectual property, in terms of, confidentiality that to be very clearly defined. I think for me, that's a big challenge when you look at it, driving co-innovation. That's number one, right? Number two, if you look at it, it's more of, lack of understanding of the customer's needs, not only the customer needs, the customer need, right? I'll give you a very good example from my previous example rather than talking theory part. So if you look at this, the Lifebuoy hand wash Unilever, right? So that point of time, they really wanted to increase the market share of this particular product. And they wanted to create a separate segment for children. So because they wanted to increase hand washing habit of children, right? I'm talking about pre-COVID era. After COVID era, everybody's washing. So the pre-COVID era was completely different. So what they did is they came to, at that point of time, we were working with Ashland. I can share the name. So they came to us and said, how can we create a differentiation on the Lifebuoy? Is there any way you guys can help? Finally, what happened? They gave one idea. It's a fun concept, that when if you have to encourage children to play with that, it's a fun that will make them to, use this Lifebuoy. So finally, what happened? Ashland gave a kind of, colored beads which are suspended in the Lifebuoy with some, active inside the suspended bead. And when the children, washed the hand, the beads got burst and active release. Because of change of pH, there was a color change. So the red color beads became a green color bead. That's why, if you see that marketing, they said it's a Lifebuoy color changing bead, right? So when that happened, so because of the color change, and people, the children found it was a fun and they started working. And the market share, finally went up on this Lifebuoy, hand wash. So that the point I'm trying to make here is understanding the customer's customer, in this case, consumer. It's not only a B2B. It's not between Ashland and Unilever, right? It's a consumer, understanding of the consumer need. So the real innovation gets created when the B2B ends up in C, consumer, right? That's an example. So this lack of understanding might need to a lot of challenges, in creating co-innovation, number one. Number three, this is number two. Number three, if you look at it, lack of involvement of cross-functional team. It's very important in any co-innovation project, right? It's operational team. It's not only a product development what we do. It's more of a, creating value to your customer. So the supply chain team, the R&D team, the operational team, sales and marketing team, involvement of cross-functional on both the side, the customer and us, it's very critical. I'll give you an example. Again, going back to my old story of Unilever. You all may be knowing the plastic coated Vim bar, right? The detergent bar which is coated by, UV curing polymer to give a water resistant, right? So initially we decided on a waterborne polymer, and the case was moving, and suddenly the operation guy from Unilever came. What is more important is productivity. I'm going to make millions of bars. If these waterborne polymers are going to take a longer time to cure, it is not going to help. Based on that feedback from an operational team, the whole technology got changed from a waterborne into a UV curing mechanism, which gets cured in a fraction of a second. So what I mean, involvement of a cross-functional team is very critical. And if we don't involve, I think that's a gap we need to really look at, right? And the fourth point, if you look at it, again, you should have an agile and flexible product development, scheme. For example, if you look at the same Vim bar, they were very successful with this, UV coating. But then they have started working on a, RIN bar. Can we look at the same technology on using in RIN? But then, we started working on that same kind of polymer approach. Then they came back and said, we solved the problem using a simple acrylic-based fiber net, which absorbs water and keeps the detergent dry. So all that I'm saying is you need to really be ready and flexible for a kind of product development. And the last one I would like to bring in is the focus on sustainability and, the goals of your customer and a partner understand, right? Today, if you're working on a, export product, for example, Europe and US market, you have to really look at it to CMR, CMR free product, carcinogenic, mutagenic, reprotoxic free product, So I think that is very important. Lack of understanding of these things, whether it is REACH registration in Europe, I think that will also spoil your kind of co-innovation. I think, see, these are some of the gaps we need to have. And again, people need to adapt. People talked about digital tools and most important, a commitment and investment into R&D in terms of resources. So I think these are the major gaps I find, which might derail a co-innovation.
So thank you, sir, for talking about real case studies and how it has been solved through co-innovation. I would request Mr. Tapan Kumar Dhar to what we can say, talk more on this topic as we move forward. If you can unmute yourself, sir.
Yeah, sorry for that. Yeah, what I said was that we are close to the 4:30. So do you have some time to speak, or how you want to close? And let me be very clear on that.
Short answers, and we extended 15 minutes.
Yeah, okay. So, just to add on what Venkat said actually on this. So, he gave some example on industrial perspective. So when we collaborate with the industry also for co-invention, and also we collaborate with the academic institutes also. So I think since the industrial part has already been covered, I will touch upon the my experience also with the academics part. So very, very well said that when we are co-innovating with a partner. So first point is getting the right partner who has that type of work exposure and who has really done the real life study. What exactly is the required for the industry? So when you go to the academic collaborator, they do not have much of idea of the actual user's requirement, and that is one big problem. So what we the gap can be bridged that when we have a shared goal and also measurable deliverable. I think these two are very, very important, that we should have a shared goal, what we are going to achieve, and then we should have a measurable deliverable, because one scientist, he might be very happy on discovering some molecule, but whether this is techno-commercially viable or not, that also needs to be seen. Whether this can be scaled up or not, that also needs to be seen. So this assessment should be a part of the discussion, what we should have at the very beginning. Second point I would like to add here is the timeline. When people are in the industry, they are forced to complete certain things in certain timeline. But with the working with the academics or maybe some of our industry partners also, the timeline and the cost when we add on, a lot of things really doesn't go ahead. So these are the 2 points I wanted to add. And last mode is that when you go for a this sort of collaboration, another point is having faith and trust, and also what sort of IP protection we are going to have. This is another point, and one should be very, very clear from at the very beginning itself. Okay, how to bridge this part, whether it's a ownership of the company who is sponsoring the project or partnering with the client, and also how much they are flexible to allow the partner actually to share the data. So these are some of the gaps: measurable deliverables, IP protection, cost aspect, and the timeline. If we are able to bridge these things at the very beginning, I think this should be able to address.
Thank you, Tapan Kumar Dharji. We come to the 6th question, and this is about open to adapt to co-innovation strategies. What are the political challenges you foresee in driving this in the chemical sector? And I would request Mr. VP Joshi and Mr. Sanjeev Gupta ji to be very precise on this part, so that we can end the session as per extended timelines of 4:45. So over to Mr. VP Joshi and then Mr. Sanjeev Gupta.
I'll start actually. See, one thing, what challenge basically I feel will be resolving the IP thing, because who owns IP is a slightly dicey scenario. In India, IP is certainly still not known much to lots of people. And now when you are doing a code development actually, so how the IP will be shared, how that the benefits will be shared, that will be a big challenge actually. And as of now, basically that's what has not been happening actually till date. So in that type of work. Especially most of the work is happening only with institutes actually. So generally institutes are not commercially so much of this thing. They work on a fees and they work out, they leave the rights basically on IP. But that is one area which has a conflict, and I think so that has to be worked out with. And in India, again, the IP framework is very weak. Organizations do lots of work and then they don't file IP, or if IP is filed also, and you will see a clone of that comes out immediately, suddenly. Or if you're working as an organization, if you work with a raw material supplier on a new technology or this thing, you will have a basically agreement with him on exclusivity. But what we have seen is that the commitment from the suppliers or the other parties is not so strong, and he will give a different clone. That raw material supplier will give some other modification, a small specification, and will be made available to another suppliers. And that what defeats the purpose actually of co-working actually. So that supplier to supplier correlation or that privacy has to be strengthened actually. What other speakers have also spoken, I find that alignment of the goal is a bigger issue in India as of now, and that will be challenged because measurables are not clearly defined many times actually. And if clearly measurables are not defined, your output will certainly not be there. Then there is a time frame are also like what you said clearly, Mr. Dhar said clearly, ki yes, the time frame, private industry will look for a particular time frame for launch a product, while an institute works on a theoretical approach actually on developing the concept, etc. So that's a big challenge actually, and there are bigger issues of funding because each organization has a particular fund, and in case of you have collaborating with an institute, etc., and funding goes beyond plus minus of the organization, that becomes a process. Also on the government fundings also, nowadays like government institutes are also coming up with a collaboration with private companies so that to develop the technology. In that case, we find that the funding is not sufficiently adequate. Another challenge is in India, there are technical labs or R&D labs, private R&D labs are still not there. Who has that level of requisite R&D strength or knowledge base, which can do all the types of job actually. So having that type of specialist R&D or the skill sets is a challenge actually, and that has to be developed basically. Then what I feel again is a challenge is a supply chain of raw materials. You develop a raw material actually or develop a new product. Like we give an example, I'll give an example. We worked on a raw material from a supplier. If that feed source of that supply was basically from outside the world actually, from not in India. And because of the government change in regulation, that raw material was not possible to come in India, and whole 2 years of the development work was lost actually. So for us, we had to start off from zero. So those regulations, etc., nobody goes in detail actually. So that is again a challenge of supply chain from where you will source a raw material. That becomes a very critical actually. And that's it. Similarly, like recently, government is in India has brought in a regulation. So like biocides, certainly all the biocides which are coming in India should be registered. Now, if you have done some bought in a new technology from somewhere else, and the biocide is somewhere you're basically not part of that, you will lose a time of 1 year. So regulations is one very important thing actually, and a challenging area one has to work out at regulatory compliance part actually, because government of India is working on changing lots of things. Certainly in chemical industry, that level of rigor is certainly not there. But I think so it's a matter of time where we still don't have a regulatory listing of all the chemicals, etc. in India. It's a matter of time. It should happen actually there. And what we find is a cultural is a big issue in each organization actually. We find actually many organizations are risk averse. If you have a risk averse development in a co-work, then the timing will go for a loss, or the cost of developing a product will be very high actually. So these are some of the points basically which will, there are lots of things basically, but looking at the paucity of the time and we are overshooting, I will stop actually at this place. Maybe ask Mr. Joshi to take further actually.
If you can add on what he has already said, Sanjeev ji. Please go ahead, sir.
Hello.
Yeah. So thanks. So basically, these challenges. So basically, definitely there is a benefit with the co-innovation. We have the like the enhancing the problem solving, enhancing the operation efficiency, promoting sustainability, mitigation risk, shared resource utilization. So there is a benefits of this co-innovations, but there are some challenges which we are seeing. The first challenge which we is the culture difference, because this culture differences means diverse work cultures and decision making process among the groups. So that can create the frictions and making this changing to align on goal and timeline, challenging on the goal and timeline. Second one, the intellectual property, IP. So protecting proprietary information while sharing the uh, knowledge with partners can be tricky sometimes. So concern over the IP right may limit the openness needed to effective collaboration. So this is one of the concerns. Second is misaligned goal and priorities, because different objective can lead to conflict the strategy and the executions, which can reduce the focus and impact the results. So this is another challenge. Communication barrier is also the one of the big challenge, and resource and time constraint. So these are the some challenges which we see these collaborations. So these are the some my viewpoint. Thank you.
Thank you, Joshi ji. Now I come to the seventh part, which is about co-innovation reshaping the future of chemical sector and how opportunities can be unlocked using this model. I request Venkat sir, if you can be short and precise. You are the only person.
Yeah, yeah. Well, again, the co-innovation, really shapes the future of this chemical industry. Today, if you look at it, the geopolitical situation, where everybody looking at a plant next door, and second, there's a overstore capacity and lower demand across the globe. So, how can this change into the whole industry? I'll give an example. One, I think, number one, what will happen is the industry will move towards kind of providing high value solutions to the problem. For example, so we will be moving into solving an industry problem, working into high value creation. I'll give you an example what we have worked in, right? If you look at it today, any of the windmill, whenever you travel across, you can see the wind blade across, right? These wind blades are nothing but a thermoset composite made out of, glass fiber and epoxy based composite. The challenge with all this wind blade, why only wind blade, the entire, thermoset composites world, right? Whether it is skiboard, snowboard, surfboard. The challenge is all about end of the life cycle. These composites are either landfilled or incinerated. Both are not an environment friendly option. With more regulations coming in, is not allowed. So we have addressed that problem. We have kind of collaborated with Siemens Gamesa globally. Then the first world recyclable blade has come out with our technology. So we have come out with a very innovative patented recyclamine curing technology, with which once you make this thermoset composite, at certain condition, this composite can be recycled to give the thermoset become thermoplastic, and the whole glass fiber or a carbon fiber can be recycled and reused. Okay. So this is basically addressing an industry problem. This is a power of innovation, right? Today, I don't think, alone we could have done it. With the help of Siemens Gamesa, we have really done this innovation. We got an innovation award on this. So one, I think it really helps you to address the industry problem and takes you, different level in terms of growth, particularly the bottom line. And second most important, I just wanted to share. So again, just to conclude, it's not only a proud moment for ABGite, but it's a proud moment for every Indian to say that we are the first Indian company to address this recyclable composite problem in the world. And we are working, and we got a global innovation award. It's a perfect example, how it can reshape the future. And the last comment from my side is, what will happen is this innovation, right? It will try to enhance your what you call the sustainability and green revolution that is happening, right? From the time in 1990, when I started my career in chemical industry, from there onwards, we have seen about this mercury free, then you have formaldehyde free, you have ammonia free, you have anhydride free. Now we are talking about BPA free, we are talking about melamine free, styrene free, right? CMR free, toxic free substances. I think it's good that's happening. I mean, the regulations happening across the globe. This will really shape up the whole chemical industry, will change the perception of the chemical industry today. For example, one of the panelists mentioned getting a new talent into the industry is a big challenge today. If I have to go and recruit somebody in the chemical industry, by getting into these regulations, if you are able to get a better process, efficient process, contribute to the lower carbon emission, this is going to attract talent and it will change the perception, the hazardous, dangerous perception of the chemical industry. I think it's a much more gain for the whole industry as good. I think that's where I would stop here.
Thank you, Dr. Venkataraman. Now I come to the last and the concluding remarks from Mr. Bhaskar Sinha on how do you think AI-based co-innovative solutions can help in faster innovation and product improvement? So your 60 seconds, sir, so that we can take up 2-3 questions from the audience.
Sure. I think the short answer is definitely yes. We have a lot of examples here. We have the panelists, let's say, from the paints industry, where you can use the data for your formulation, you can use the data for your better improvement of the production, and it's the same with every industry. And we have shown some examples. My colleague Prashant showed that how we are using this color optimization solution, which uses the AI there to recommend what kind of pigments should be added in what quantity. Now, what is important here is to understand what are the challenges that are in there in adoption of these AI technologies. Number one is the availability of the data. So this data is either available in a way that is not accessible, or if it is accessible, you're not leveraging it, or it is not created at all. So in our case, we had to innovate many of the places with the measurement system to capture the data, right? So data capturing and the synthesis is a big problem. Second is the domain understanding. If you get the data, what do you do with the data if you don't understand it, right? So it's extremely important that you have the domain understanding to leverage the data to your advantage. Third one is that, of course, you can use that to capture knowledge and bring in more automation, because you have these industries running for a very long time. How you can use the people who have been knowledgeable in this space through this technology to capture that information and reuse that information to help you do better jobs in future. And the other important part is the protection of the IP, several of you mentioned in there. So when we build these technologies, we have to ensure that the data and the IP resides with the owners and it doesn't leave them. So whatever technologies we build, it has to be built in that manner that it safeguards the interests of that owner and the person, so that or the company or the organization, so that they don't lose their competitive edge as they are trying to embark on this new journey with these new technologies. So these are some of the things that I thought that I would add to this.
Thank you, everybody. Let me take few questions. It would be what we can say not good on our part to not answer any of them. I have taken a few of them, and I would request all of you to give short answers. I am clubbing 1 and 2 question. One is on how data analytics is useful to industrial innovation, and this is from Dr. Vasant Chabukswar. And the other is on how can IoT help chemical industry, and this is from Sachin. My take would be that both are very important, and most of the industry people sitting here are already deploying both these technologies to make what we can say better product, efficient operations as we move forward. But let me have some views from Mr. Bhaskar Sinha. Your short answer, sir.
Yeah, as I mentioned, it unlocks new opportunities, because what you don't know is what you don't know. This data allows you to see what's happening, and that allows you to open up new possibilities. So in short, if you are able to leverage this information and data, you can open up new possibilities to meet the demands of the industry or open up new opportunities. Now, on the IoT side, yes, there is already a trend where the data is moving down on the edge so that the data is protected There's one report which says that there is close to 1 petabyte of data that would get generated by the industrial automation or the industries per month, right? That's a humongous amount of data. You just can't send all of it to the cloud, right? So you need to use IoT, you need to process the data, and you need to leverage that data.
There is a question from Vidya Chatterjee, and she is talking about to catch up with the technological advances in addition to the market share. How can chemical companies stay agile enough to incorporate disruptive innovations from the external partners involved in co-innovations? And I would request short answers from Tapan Kumar Dharji and from Dr. Venkat. If you can unmute yourself, Tapanji.
Right. So the question was that how we can leverage the advantage of external innovation. Am I right, or what exactly was it?
And the partners with respect to co-innovation.
Right. I think all those all along whatever we have discussed is mainly with that. But the big challenge is how. So first of all, at times when you are referring to different academic institutes, we do not know exactly what is in their kitty, what is available, and how we can make use of that. Whether it needs to be fine-tuned to meet our requirement, or these are already readily available. But most of our experience is it's not readily available. You need to fine-tune that. So there has to be collaborative further work to really meet our exact requirement. That's one point. Second thing is also when this sort of help we get from them, that commercial aspect are most of the time are not being considered. So when we consider that, most of the projects are not feasible. That's why when we sponsor certain projects, the institutes or academics, very beginning these things are clarified. That's my response to the query.
So Venkat, your short answer.
So very quickly, I gave a very good example on the disruptive innovation, about coming out with a recyclable composite using a recyclamine technology or innovative patented. This is a perfect example, for example, if you use it, to making, let's say, the snowboard, ski board, surfboard, all this can be recycled and will contribute more towards the environment and sustainability, number one. I gave an example of the wind blade. And similarly, even if you look at in India, right, if you look at an LPG cylinder, now we are really working with IOCL to convert that LPG steel cylinder into a composite cylinder. You might have also seen this has been launched already in India. It's again a disruptive technology. If you look at a composite cylinder, the weight of a composite cylinder is just 4 kilo when compared to the 14 kilo weight of a steel cylinder. And the most important, even you can see the level of liquid inside it. And it's absolutely safe to use it. So it's more important to look at this disruptive technologies. Even if you look at this rebars used in construction, right? The steel rebars today, if you look at it, there are companies working on to convert into composite rebar. One, I think absolutely no corrosion till the end of the life cycle, and then it can be recycled. Number two. So all that I'm saying is most important if you're really looking for the leapfrog growth in your company, most important is to look into disruptive innovation and not the incremental innovation. Thank you.
Sir, this question is from Narayana Murthy Sekhar, and his question is how efficient is co-innovation with Indian industries and institutes? And I would request Sanjeev Gupta ji, who has an experience of working with the CSIR lab. So if you can talk about that.
It's basically we can easily work with institutes on collaboration actually. So one has to give them project well in advance, and then based on the projects, there is you give the timeline etc. and work it out. So all the institutes, what I've seen is that they are open to work nowadays. One advantage what I see with them is because of the government funding, they have good your testing instruments, etc. So the testing, etc., is pretty good possible, or they share actually, like they can share from some other institutes and do a testing, etc. possible. So I find the institutes, they are far easy to work out. Only the cost, etc., timelines are to be you have to put up a system of review mechanism actually, so that you meet your timelines. That's the way exactly.
Thank you, Sanjeev ji. Mr. Nitin Mahajan is talking about primary drivers of co-innovation in the chemical industry. We have already discussed in this entire webinar, but Rajesh ji, if you can just summarize for Mr. Nitin Mahajan.
So as I said, the primary drivers are, essentially the problems that we are facing today are quite large, and the resources, expertise, and the risk involved are also equally large, and we need to spread it across. And the only way to do that is to ensure that, there are multiple parties who are collaborating and working on it, and they bring their own expertise. They assume their part of the risk, and if the solution works, then everybody benefits.
Thank you, sir. To Mr. Vinod B. Joshi, is green hydrogen the future? Joshi ji, your views, sir?
Yes, basically, green hydrogen is the future for the chemical industry because lot of chemicals is depend upon the hydrogen. So this hydrogen is important for us, even though fuel to replace the fuel or hydrogen-based vacuum. So definitely hydrogen is the key for in the future business.
We have done a lot of webinars on hydrogen. In case you want to have a look at it, please visit our website, indianchemicalnews.com, and all those videos are out there. The other questions we have already answered. There was a question on future of chemical industry needs to be regulated by adopting process safety standards. There is no doubt about that. The question is from Mr. Pramod Parikh. Mr. Rajendra Gorati talks about how much industries would like to collaborate with academicians. This also has already been answered. And then Sanjay Chaudhary is talking about how platform enhancement and AI/ML based technology help in predicting customer insight. I think we have discussed during the course of the webinar. And then this is again about the safety part, which has already been taken. So thank you all my panelists for enriching all the delegates with respect to co-innovation. A big round of applause to all my speakers, Dr. Venkataraman Balakrishnan from Aditya Birla Chemicals, Mr. Rajesh Kamat from Tata Chemicals, Mr. Tapan Kumar Dhar from Berger Paints, Mr. Vinod P. Joshi from India Glycols, Mr. Sanjeev Gupta from Shalimar Paints, Mr. Bhaskar Sinha from Schneider Electric, Mr. Prashant Chandanapurkar for his presentation from Schneider Electric. So thank you, sir. But before we go, I would request those who have not filled up the form, please fill it up for the sake of our partner. And let me also announce the winners of the ICN Play and Win quiz contest. And so the question one, the winner is Mr. Siddhant Gupta from Bharat Petroleum Corporation Limited. The second question, the winner is Vidya Chatterjee. She was the one who was also asking questions. So she is the winner for the second question. And the third is Mr. Harshil Bhanushali from Aarti Industries. So we will send you Amazon gift coupons by mail to all of you, and congratulations for winning Amazon gift coupons, vouchers.
Congratulations.
Just let me do some thank you note.
First, thanks to you, Pravin.
Thank you,
for
sir.
initiating this panel discussion and bringing all of us together, so we also could learn from each other and understand it, right? Great.
Thank you all the speakers. Thank you all the delegates. Those who have not attended, they can have a look at the video part of it. And thanks to all my team members, ICN team, who made this happen at the back end. And once again, namaste, and thank you all from Delhi. To meet you again for the next webinar. Namaskar.